Hello and welcome to Otten Math. In this edition of Otten Math, we are going to talk about formulas for addition and subtraction for tangent. Right, so the goal is to know and apply the addition and subtraction formulas for tangent. Rationalizing the denominators and solving complex fractions will be part of the lesson. Right, so complex fraction is really a fraction in a fraction. So an example 1 plus x over 3 over 2 minus x over 2. So how do we handle these complex fractions? Well, we simplify the numerator and denominator, and then we're going to multiply the numerator by the reciprocal of the denominator. So let's take numerator and denominator separately. 1 plus x over 3, we have to find a common denominator, which ends up being 3. 3 over 3 plus x over 3 is equal to 3 plus x over 3. Then taking the denominator, 2 minus x over 2, common denominator is 2. 4 over 2 minus x over 2 leaves us with 4 minus x over 2. Now we're going to multiply the numerator by the reciprocal of the denominator. 3 plus x over 3 times 2 over 4 minus x leaves us with 6 plus 2x over 12 minus 3x. So a simplified fraction means that all terms have no common factors. So in this case, this is a simplified fraction because all the terms don't have a common factor. So we're going to leave it in this format. All right, what is a term? So a term is a single number or variable. Numbers and variables multiplied together. So we have 3y as a term, negative 2 as a term, 7x as a term, and plus 4 as a term. So it's a single number or variable, or numbers and variables multiplied together. All right, so simplify this. I'm going to pause here while you figure this out. All right, so we have no common factors in any of the terms, or in all of the terms, so we're going to leave it as is, 2x minus 7 over 2. Let's try another one. Simplify this one. Okay, we have common factor of 3 in each of the terms, but x and y are not common factors in all the terms, so we can't simplify them out. So it ends up being 3x plus 9y over 2y minus 4x. All right, simplify this problem. Okay, if we multiply the terms now, we combine the terms, x and y become part of one singular term, and I end up being able to simplify or reduce x over x, y over y, and then I have a common factor of 9 between the two terms, and I end up with 27 over 8 as my simplified fraction. Okay, rationalizing the denominator, that means we don't want any radicals or fractional exponents in the denominator, and no complex numbers in the denominator. So for this section, we're just going to simplify the radicals by multiplying by the denominator radical over itself. Let's go through an example. So we're going to rationalize this. We have a radical in the denominator. We're going to multiply by root 7 over root 7, and I end up with 3 root 7 over 7. So no radical remaining in the denominator. I call this hairbrushing because we're just changing the way that this fraction looks. We're not changing the value because we're multiplying 3 over root 7 by 1. Right, so for this section, we're going to rationalize two-term denominators by multiplying by the conjugate. So in this case, 3 over 2 plus root 7. You can attempt to solve this by pausing, or I'll go through the answer. We're going to multiply by the conjugate of the denominator, which is 2 minus root 7 over 2 minus root 7. So again, this value here is just 1. I end up with 6 minus 3 times root 7 over negative 3, which is minus 2 plus root 7. So I go through the math here if you want to take a look at that. All right, so moving on, rationalize this problem. I'll pause here while you figure this out. Again, multiplying by the conjugate of the denominator, we end up with 8 plus 4 root 3 over 4 minus root 3, which ends up being 8 plus 4 root 3 because 4 minus 3 is equal to 1. Okay, so now we need to use this in order to solve for the sum and difference formulas for tangent. All right, so let's solve for the tangent of 75. I'll pause here while you figure this out. All right, so this is tangent 45 plus tangent 30 over 1 minus tangent 45 tangent 30. So the numerator ends up being 1 plus root 3 over 3, which equals to 3 plus root 3 over 3. Let's take the denominator. 1 minus 1 times root 3 over 3, which is 1 minus root 3 over 3, or 3 minus root 3 over 3. Now we're going to multiply the numerator by the denominator. 3 plus root 3 over 3 times 3 over 3 minus root 3. And I worked through the math here for you. You can evaluate this, and you end up with 2 plus root 3. Okay, next, tangent of 195. I'll let you figure this out. Pause here. All right, this ends up being tangent 135 plus 60. Working through this, I end up with root 3 minus 1 over root 3 plus 1. And multiplied by the conjugate of the denominator, both the numerator and denominator, and I end up with 2 minus root 3. Next problem. Okay, so now I'm going to go in the other direction, tangent 100 plus tangent 50 over 1 minus tangent 100 tangent 50. This ends up being tangent 100 plus 50. Or I can rewrite this as negative tangent 30. I evaluated here x over x root 3, which is equal to x over x root 3 times root 3 over 3, which is equal to negative root 3 over 3. Next one, tangent 75 minus tangent 30. Pause here. This ends up being tangent 75 minus tangent 30, which is tangent 45. Tangent 45 is equal to 1. All right, so we're going to use a tangent addition formula to solve for tangent pi force plus theta, where tangent of theta is equal to 1/2. So let's see if you can work through this problem, and I'll show you the answer as I pause. All right, this ends up being tangent of pi force plus tangent theta over 1 minus tangent pi force tangent theta. 1 plus 1/2 over 1 minus 1 times 1/2 is 3/2 over 1/2, which is 3/2 times 2, which is equal to 3. Cotangent of negative 15. I'll pause here while you figure this out. Okay, cotangent negative 15 is negative tangent 75 degrees, which I can rewrite as tangent 45 plus 30. Tangent 45 plus tangent 30 is equal to 1 minus, tangent 45 plus 30 is equal to tangent 45 plus tangent 30 over 1 minus tangent 45 tangent 30. Numerator 1 plus root 3 over 3. Denominator 1 minus 1 times root 3 over 3. And as you work through the math, you end up with negative 2 minus root 3. All right, and then here's just a graphic of how you work through the similarity between cotangent negative 15 and negative tangent 75 degrees. All right, so that's it for this edition of Ought in Math. Join us next time when we talk about half and double angle formulas for tangent and cosine and sine in the next edition of Ought in Math.